Did you know we have already accumulated 44 zettabytes of data, which is equal to 44 trillion gigabytes of data, and that too only till end of 2020. Information explosion was the term first used in 1941 by Oxford Dictionary. If this points makes you curious who's generating this data and how can we leverage this data, then you're in the right place. Hello, my name is Sandeep Fabiani and welcome to fabianitech, wherein we'll discuss all these points. Okay, so in this we'll be discussing the introduction to big data, wherein we'll understand the need for big data, what is big data, how can we use big data, and what are the vendors that provide big data solutions. Now, data is everywhere. Right from the point that you pick up your phone, you access Facebook, WhatsApp, Twitter, send or receive emails, the information that is coming from the weather department, whether it's going to rain today, whether it's going to be humidity, whether it's going to be your traffic signals, whether you look at your Google data, wherein you commute to work, you want to go to a new place, okay, let's access Google Maps. So all these data is being accumulated. Now, anything and everything, right from the point that you access any website to understand, okay, let me learn something new. You access Twitter, you access YouTube. So all these things, everything is data and data is everywhere. Now let's have an understanding of how much data is being generated. So we have an image from Raconteur, okay, wherein we can see we generate approximately 500 million tweets. We send out at least 294 billion emails per day. We generate 44 petabytes of data every day on Facebook. Around 400 terabytes of data is being generated by each and every connected car that is out there. 65 billion messages are being sent over WhatsApp on a day-to-day basis. And on an average, it is seen that around 5 billion searches are being made. There's also an expectation by the end of 2025, there'll be around 463 exabytes of data that will be generated, which is equal to around 212 million DVDs if you're from that zone. Okay, now one would say, okay, what is the limit of data and how can we understand what are you talking about, zettabytes, yottabytes? So okay, let's have an understanding of what these data really are. So as you can see, right where on day-to-day basis, we hear kilobytes, megabytes, gigabytes. So as you can see, kilobyte is around 124 bytes, okay, which is around 8 bits. Megabyte is 124 kilobytes, gigabyte is 1024 megabytes, and so on and so forth. And as you can see, the unit that we have reached is something called as 1 yottabyte, at least 1 yottabyte. Now you would say, okay, let's have an understanding what exactly is a yottabyte. Okay, so we are aware of the day-to-day gigabyte that we really use. Okay, so 1 yottabyte is equal to quadrillion gigabytes. Okay, so it's that huge of a number. Now one would say, okay, we are generating that kind of data. Where exactly this data is being used? So we have many different big data applications, right from your banking and securities, what is being transferred, how it is being transferred, your payment gateways, your Amazon payments that you really do, your account-to-account transfer, so on and so forth. Even in insurance data. So you hit your car, what will be the amount? God forbid someone gets hurt, what will be the amount? How will that be leveraged? So even used by the insurance firms. Transportation data. So right from your signaling data to your connected car data, which we discussed earlier, to Google Maps. So all this transformation is being used. Another domain that big data is used is in education, wherein what is being generated, how is it being generated, how do we leverage that, all the history data, that is also one kind of big data that we really use. It's also used in manufacturing domain. Now one would say, okay, how would it being used in manufacturing domain? So it is used to track the demand and supply, what is out there. Okay, in addition to manufacturing domain, it also used in healthcare domains. So something like in today's world, we see that a lot of diseases are really coming up. The latest, which is the corona, which occurred in 2020. So all this data of all the human categories that are really out there, what diseases, what DNAs, all these things are really collected into some databases. DNA databases being one such example. So it's being highly used in healthcare domains, media and entertainment. one of the favorite things we really all are aware of. So your YouTube videos, your Facebook videos, your movies, your Netflix, your Amazon Primes, your music libraries. So all this thing really is catered over on big data. One would say, what is big data? So let me give out an Oxford dictionary kind of a meaning. So it says extremely large data sets that may be analyzed computationally to reveal patterns, trends, associations, especially relating to human behavior and interaction. Now one would say, dude, Sandeep, what are you really speaking? I cannot understand a word out of it. Okay, what are you exactly trying to say? So let's look at one of the more easier to understand definitions, one given by IBM. Now, if you see the screenshot in front of you, so IBM states big data consists of 4 parts: volume, variety, veracity, and velocity. Now, what is volume? So volume is nothing but the amount of data that is being generated. So it can be by clickstream data, the website hits that you really do, the active and passive sensors. So I really talked about the IoT sensor, the weather sensors, application logs. So if you're from the technology domain, you'll understand what are really application logs. So application logs are nothing but the logs, the data that is really being generated when you click a website, or when the Facebook things are, you post a post on Facebook, Twitter feeds, so on and so forth. So what is really happening on the backends? All these logs are generated. So even that can be used to understand what the user is really wanting out of the whole thing. Okay. Now, printed corpus. This is one such paradigm of it. When in newspapers and all those pamphlets that you really see. So even that kind of data is huge. Social media, we discussed Facebook, WhatsApp, Twitter, etc. Event data, so anything right from the part where a user says, okay, I want to see what's the weather. So all these are events that are generated. Speech data, so Alexa, Google Assistant, all these applications are being, they are generating a lot of data in terms of volume. So variety. Now, what is really the variety? So data can be part of three. It can be one of these 3 things. It can be unstructured data like images, videos, sounds, etc., etc. It can be semi-structured data, so having some kind of structure. So like tweets, they are of a certain character. It would have images, it would have sounds, etc., etc. Emails, it can have attachments, it can have it from, to, so on and so forth. So, and the third variety is definitely the structured data, wherein there is a perfect structure to what the data is. So something like a star rating. So anywhere that you see, okay, whether you like this website, whether you like this YouTube video, you rate it. Okay, I like 1 star, 2 star, 3 star, 4 star. So all these stars, so variety, that's the kind of variety of data that is being generated. Now the third part is the velocity. Velocity is nothing but the speed of generation, the rate of generation, and the type of generation. So what I mean by velocity? The speed of generation. So as we talked about in the previous slides, we are generating a lot of data. So tweets, posts, so on and so forth. At what rate it is generating? I mean, how many users are active at a time and how much data is being posted. So it's so something like, it's observed that once a person reaches home, he's on his social media. So at that time, the rate of generation of data is more. Okay, so rate, speed, type of generation. So it is generation in streams or is generated in batches. So what I really mean by stream or batches is, stream is it one continuous flow of data, or it is more of a batch kind of a data. So consider the banking example. Okay, so when you do a bank to bank transfer, so at regular interval time, one bank tries to send out money to the other bank. So it is done at every regular intervals of time. So those is nothing but batching, wherein you accumulate certain kind of data and then send it out to a system in batches, in parts, in portions. So that is what is batching. And streaming is continuously data. I mean, you, as soon as you click send on transfer money, the money is transferred from your account to the recipient account. So we talked about volume, variety, velocity, and the last one is veracity. So veracity is nothing but data quality. So what I really mean by data quality is whether the data can be trusted, so whether it can be untrusted, whether it's cleansed, whether it's uncleansed. So what I really mean by cleansed or uncleansed and trusted? So data can come in from various sources. Okay, So for example, data that is coming in from the IoT device is something like a weather sensor, which would predict whether it would rain or not. Okay, so it would always keep on accumulating some kind of weather data or the other. But we see, okay, at a particular interval, we can see that the heat increased. So that means it is humid. So that kind of data. So under a specific, so consider an example wherein you have 1 hour of IoT weather sensor data. So not every minute is really important. You would aggregate into an hour, and then you say, okay, for this hour the humidity would be so and so, and then you can have some prediction models over it to detect, to understand, and to predict what will be the weather at the end of the day. So we talked about volume, variety, velocity, and varsity. So these are the 4 V's that really define big data. Okay, now you would say, Sandeep, what is our end goal? You're talking about data explosion, but what we really not are talking about, what is our end goal? How can we leverage this data, and how can we make meaning out of this data so that we can understand more with respect to what we want the desired result. So what we are trying to do is, so as you can see in the image, we are trying to take data from various sources, apply, massage, extract the data that is really required, and transform it into a graph or some kind of reports so that we really understand what this data really means. So that's our end goal. Now, how would you achieve it, and how would big data help you achieve it? So big data, in the big data paradigm, we have around 6 such parts. Okay, so first part, as you can see on the extreme left, is data sources. So we talked about IoT sensors, nothing but the weather sensors, social media data, log data, mails, logs, emails, and then we have something called as databases. So if you're from the technology paradigm, you'll understand what are databases. Databases are nothing but the persistent storage where the data is being persisted for a specific period of time. So something like, you go back to your banking application and then you see, okay, give me the transactions that are in the last 10 days. So that data is stored somewhere. So databases is that storage area. So we have all the data sources, and then we have data ingestion layer. So big data gives you 2 such examples, which is Apache Flume and Apache Scoop. So these are applications or softwares that allow data to be ingested into the big data environment. Okay, now data can be unstructured. Okay, so how would you store this structured? So it can have application, it can leverage softwares like Apache Kafka, or you can store it in something called as Hadoop HDFS. We'll be discussing this in the coming YouTube videos, but yes, we'll definitely touch upon them. Data processing, so something like Apache Storm, Spark streaming, Hadoop MapReduce, Apache Sparks. So all these things are nothing but applications that you can actually massage your data, make meaning out of it, and then you can transform your data from one form or the other to get the desired output. Now, once this data is extracted, you would require to store it. So once a storage mechanism is Hadoop HDFS, Apache Sbase, Cloudera Impala. It can also be stored in Avro format. So the Avro is one such a format wherein you can save big data. Parquet, Cassandra database. So it's a kind of a database, a data storage layer. So herein you can, once your data is processed by all the Apache applications like Apache Storm, streaming, Hadoop HDF, MapReduce, Apache Spark. So once these data is processed, we can store the structured data into all these databases. And then once this data is stored in the databases, we can obviously imply analytical tools like Spark SQL, if you want Spark SQL or Hive, if you want to get data in a particular SQL format, Apache Mahout. And so basically all these things are nothing but the SQL kind of things, SQL's kind of interfaces wherein you can get data out. If you want to do machine learning kind of a thing, so there's something called as Apache Spark MLib, which gives you a machine learning kind of paradigm wherein you can extract the data that is really desired by you. Now, last point, what are the big data vendors that we really have? So there are 3 main vendors. One is Hortonworks, Cloudera, and Mapr. Okay, so Hortonworks is being bought by Cloudera. So, but yes, the open source part of big data is Hortonworks, Cloudera, and Map are more enterprise driven, wherein they give out paid services. Amazon Web Services is one of them, DataStax, Microsoft, IBM, so on and so forth. Now, thank you. So this is what I had to cover for the day. Okay. If you like the video, please share, subscribe, and please do follow us for the next video in this. Okay. Bye.